Hello, welcome to your Law of Sines lesson. This is lesson 5-2 on Law of Sines. What you can see here is the formula for Law of Sines. It doesn't matter if you use the formulas listed at the top here or the formulas listed at the bottom. I seem to always be used to the way I was brought up, and that was using the ones at the top, so I'll use everything above this red line. I rarely will go to the bottom. Law of sines. What is law of sines all about? Law of sines is a way of using trigonometry when you do not have a right angle in your triangle. Usually trigonometry, you need a right angle according to apply SOHCAHTOA, but in this case, you don't if you use law of sines. So the couple things that I want to highlight with law of sines is the formula you see here at the top has to deal with the fact that when you have an angle A, to set this up, the angle is the big letter A, and it is across from the side A. Sides are usually designated by a lowercase letter, and angles are usually designated by a uppercase or capital letter. And B has to go with B, and C has to go with C. And if you see this, angle B is across from side B, angle C is across from side C. So that's how the formula works, and all you have to do is set this up, use a little cross multiplication, and you're done. So let's move on. Here's example 1. This triangle here is not your strict SOHCAHTOA type of trigonometry problem. This problem here has to deal with finding the length of B, that is this side right there. Now, there's a couple bits of information you need as you go along. First of all, you have to, when you set up law of sines, you have to have the side you're missing, this one, and across from it you have to have the angle measure. Now I do in this case, so I'm going to set this up as the sine of 33 degrees over its counterpart, the side across from it, which is the side I'm trying to find. That equals another fraction, and in this case I'm going to pair up the a's. So these are my a's right there. So I always want to put the angle measure on the top, so I'm going to do the sine of 108 degrees divided by the length, 24. That's the setup. It's a really easy, simple lesson. All you have to do is cross multiply and divide, and you're done. So I'm just going to set this up as b times the sine of 108 by cross multiplying this way. That equals 24 times the sine of 33. And then to get b alone, you divide by the sine of 108. That's an 8. Cross these out. Whatever answer your calculator gives you for this, that happens to be your side B's length. So I'll give you a moment to calculate that if you want to try that on your own. See if you can get it. You might want to try it because it's not as easy as you think. The resulting answer should be 13.74. Hopefully you got that. If you had problems with it, we'll run through that in class. Here's another example. This is very similar, except we are now trying to find the measure of angle B. B is this angle, so you could find an angle, or you could find a side with law of sines. So setting this up again, the green is the sine of the unknown angle, capital B, over its corresponding across from length, equals the sine of 35 degrees over its corresponding length, 45, the across from side. So you just set this up like this, and then you cross multiply and divide, and I'm gonna always cross multiply with using the sine stuff. So 45, I like to put the number in front, sine of B equals 23, sine of 35, you divide by 45 to both sides, and the result or the answer to this gives me not angle B, but what the sine of angle B is. There's an extra step here. So I'm going to, work all this out on my calculator, and I better grab my calculator for this one. The last one I had already done already. So for this one here, I'm going to be typing in 23 sine 35 times sine 35 and then I get an answer and I divide that by 45. That gives me a decimal, sine of b, 0.29316. Try to use a lot of decimals in the middle of a problem. And then to get rid of the SIN part, you just do the inverse. So b is inverse sine, because you're missing an angle, just like in the last section. And you take the inverse sine of that, and you end up with around 17 degrees, rounding. Yeah, it's 17.04, but I'll just use this wiggly sign, 17.04 degrees. Couple other comments real quickly. Problems can be used for story problems. Now, this problem should look familiar. It was the extra credit problem on the last test, and we did 2 or 3 problems with it in the last section. The beautiful thing about law of sines is that you do not have to do this that hard way we did it in last chapter, where we had to call this 20 and then this y, and then the height of the tree is x or h or whatever you called it, and then you had to set up the tangent of 75 equals x over y, and then you'd use the big triangle and set up another tangent. You had to solve for x and set them equal to each other. Law of sines makes this a little bit quicker and a little bit better. So if I'm going to start with this smaller triangle, I need to find y. So how am I going to do this? Well, I'm going to change colors here, and I'm going to start with this triangle right here. Now I can use law of sines to find a similar piece. This one is on both triangles, the green and the red. So I'm going to find that piece. So I'm going to say the sine of 45 over this missing piece. Let me put this in brown. I don't know if brown will show up. Let's call this h equals, then I need to use this 20, because that's the only other side I have in the red triangle. So 20 over its opposite angle. Now, there are a couple things you have to problem solve here. There's a couple things I'm going to run through real quick. This is a 180-degree turn. So if this one's 75 right here, then this one is 180 minus 75. That's 105. So if I have 2 angles in a triangle, 45 and 105, I can find the third one with some simple subtraction. 10 carry the 1, that's 5, and that's 1. It's 150 for this angle and this angle combined. Some total in a triangle is 180, so this angle right there has to be 30 degrees. That's really the only trick to this problem. And then I'm going to let you cross multiply and solve that if you would like. I'll tell you what the answer is. The answer is going to be 28.28. That is this length right there. Now you can use standard trigonometry. Standard trigonometry for the green triangle is sine of 75 equals the tree, which I called x over 28.28. Multiply both sides by 28.28, x equals whatever answer this is. And that's how you do it. Now, if you kind of look at this, it may look like a lot of work, but it's way quicker than the way we did this in Unit 4. That should do it. Thanks for listening. You have a good night.